So today my topic is about hydrodynamics. First of all, I introduce myself. My name is Kamal Anaki Suresh Kumar and my registration number is 06 DKA 20F2069. My subject is fluid mechanics and my department is Department of Civil Engineering. So today I am going to present about hydrodynamics. Hydrodynamics it take two concept of flow in motion due to shear stress, and another one study the behavior of fluid flowing in pipes. And in the concept of flow in motion due to shear stress is two real and ideal fluid, and another one is compressible and incompressible. And another one for the study the behavior of fluid flowing pipe is explain the laminar flow, turbulent flow and transition flow. And about the real and ideal fluid. Ideal fluids which don't have viscosity and are incompressible, such fluids do not offer shear resistance. And the real fluids which do possess viscosity. These fluids are always offer shear resistance. And the big difference between ideal and real fluid is ideal fluid has zero viscosity, and therefore the real fluid is viscosity exists. For the ideal, incompressible, and the real can be compressible. Infinite bulk modulus, and for the real fluid is finite bulk modulus. For the ideal, no surface tension. Real fluid surface tension exists. For the ideal is imaginary and do not exist in nature, and the real fluid exists in nature. The real fluid are fluid which possesses at least some viscosity is termed as real fluid. Actually, all the fluids existing or present in the environment are called real fluids. Some of its are example petrol, air and extras. Ideal fluid is incompressible, meaning density of liquid remains irrespective of the pressure. An ideal liquid is non-viscous, no tangential forces between layers of liquid in relative motion. The ideal liquid can withstand any shear strain.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nakib bin Muslimin. Matric number 06BKA 20F2063. And I will continue with Reynolds number. The Reynolds number is ratio of internal force to viscous force within a fluid which is subjected to relative internal movement due to different velocities. Reynolds number also can be simplified as Reynolds number equals to the density of the fluid times with the velocity of the fluid times the characteristic length, the chord width of an airflow, over the dynamic viscosity of the fluid. Also, the velocity of fluid times with the characteristic length of chord width of an airfoil over the kinetic viscosity of the fluid. As you can see, with the velocity, characteristic dimension, and density is high, and the viscosity is low, the Reynolds number will become big, and the flow will known as the turbulent flow. But if the velocity, characteristic, the density is low, and the viscosity is high, it will make the Reynolds number become small, and the flow will become laminar flow. This can be seen with the difference between the types of liquid, which is water and honey. The Reynolds number also can be used to determine if the flow is laminar, transient, or turbulent. When the Reynolds number is small, the flow will become laminar, and if the Reynolds number become higher, it will become transient, and finally it become the turbulent. As you can see from the video, when the Reynolds number is small, the flow is straight and smooth. But when the Reynolds number become higher and higher, the flow become more turbulent and distorted. That's it for our presentation. Thank you.